Hey, welcome back. All right, so lesson 13, doing some more applications, more practicing with multiplying and dividing, but also applying multiplying and dividing to problems that involve area. Let's start with this first problem. To solve the problems, write your answer in simplest radical form, which means I can't put these in my calculator because most likely I will get an irrational decimal, a decimal that will go on forever and ever with no pattern. So I need to be able to know the rules for multiplying radicals to get the answer correct. So my first step is to, you can feel free to flip back to yesterday's notes, multiply the coefficients first. So I see a coefficient of 4 here. I do not see one here, so if I don't see one, I'm writing in the number 1. So my first step is to multiply the coefficients. If you want to jot these down also that's fine too, especially if you weren't sure what to do. Keep it nice and short. So 1 times 4, that's my first step. 1 times 4 makes 4. That's the product. And my second step is going to be to multiply the numbers in the radicals. So I'm going to take 12 and times it by 18, and whatever that answer is going in the radical. So again, I'm typing on my calculator right now, 12 times 18. No radicals are going in my calculator right now. The only radical there is the one that I'm writing on my paper right here. So 12 times 18 makes the product 216. Big answer. I'm pretty much done, but I need to write my answer in simplest radical form, which means I'm going to need to break down that 216. Again, I will say it again. If you're not sure what to do, guess where you're going? That calculator video that talks about perfect squares and how to simplify radicals using perfect squares. I'm going to go down my list right now. I'm looking at 216 divided by y. 216 divided by x, and I'm looking at my table right now. And I found the largest perfect square to be 36. So I'm going to rewrite the 4, and I'm breaking 216 into 2 radicals. Again, one being perfect, one not being perfect. 36 is my perfect square. 36 times 6 makes 216. And then plugging this in my calculator, 4 times the square root of 36, and I know it will be a whole number because 36 is on my list of perfect squares. And I will get 24, and my radical 6 will stay because I need a radical to be in simplest radical form. And then one final check, I'm going to put this original, I'm going to put the original problem in my calculator, radical 12 times 4 radical 18. And I get 58.78775383. 58 point something. And now I'm going to put my answer, 24 radical 6, in my calculator, and I get that same decimal, which means I did it right. Thumbs up for you. Okay. So multiply the coefficients first, multiply the numbers inside the radical second, and obviously our last step was to simplify. Now, moving over to this one. We have talked about multiplying in this way before. I'm multiplying this number, this coefficient on the outside, by not just one, but 2 different terms on the inside of these parentheses, and that is known as distributing. I would have to distribute or give out that radical 3. So I'm going to start with that first arrow. What is radical 3 times 3? Since those are not like radicals, and my rule is to multiply coefficients by coefficients, technically I'm doing radical 3, right, times 3. I'm just going to jot that on the side just so you can see what I'm talking about. Right here, my first step is to multiply coefficients together. Well, I have a 3 here, that's a coefficient, and I technically have a 1 here. So 3 times 1 is just going to be 3. Multiply numbers inside the radical. Well, I have a 3 here, but I have nothing here. So I guess I'm just going to write, right? I have nothing to multiply it by. I'm just going to write radical 3 next to it. And then simplify. I actually can't simplify this because there's no perfect square that will go into 3 evenly. Okay. I'm going to do the same thing. I'm going to rewrite the problem over here for my second arrow. I'm going to keep that minus sign in here. And so we're talking about radical 3 times radical 2. First step is to multiply the coefficients. There's a 1 here. There's a 1 here. So my answer will have a 1 as a coefficient. Multiply the numbers inside the radical. And that answer is going to go right here. What is 3 times 2? Radical, right? Not the radical, just the number 3 and just the number 2. And I get 6. So this answer will be 1 radical 6. And if you remember, when I am adding or subtracting, I need to have like radicals. Since I don't, this is my final answer. I can't do anything else about that. Right? I cannot simplify or break down 3 anymore. I cannot simplify or break down 6 anymore. And since I cannot subtract them together because they're not like radicals, that is all I have. I'm going to use my calculator trick one more time. I'm going to type in exactly what I see on the screen. And I get a decimal equivalent right here. So whatever this decimal is. And hopefully it should be the same as my answer. And if it is, then I know I did it right. And it is, so I did it right. Okay. Be sure you have all of this work copied down. Pause the video if you need to, and then unpause it when you're ready to move on. Okay, so now we're going to use that practice that we just did with the multiplying to apply that to this problem right here. Find the area of the following rectangle. You're going to need to know, but it is on your formula sheet, the formula for area. Now there is no rectangle area formula on your formula sheet, but there is one for a parallelogram, which, if you remember, looks fairly similar to a rectangle, except it's a little slanty. The area formula for a parallelogram is base times height. And if you're looking at this shape, the rectangle, it also has a base and a height. So it's basically the same formula. I'm going to write the formula I know for rectangles, which is length times width. But if you use base and height, that would be okay also. Since I don't need to label the other two sides because I'm just dealing with a length and a width for area, I don't need to label the other two, so I'm not adding them all together, even though the picture could be used that way. I am going to write a multiplication problem, this multiplied by this. The reason I'm going to put the small term in the front is because I believe it's easier to distribute that way. And that's the way that I'm used to seeing it. However, you could have also written it like this. Same, right? Looks the same, just in a different order. And if you recall, our commutative property tells me that I can change the order when I am multiplying or adding, and I will get the same answer. I'm actually going to use this top one right here. So can I move this guy over? Nope, erase it. I'll write it on the side. You guys can see it over here. I could also write it as radical 6 plus radical 3, and all that times radical 12. But I like to put the small guy in the front because I'm going to now distribute plus the I. So again, if I have to do it step by step, I can. I can do each one on the side. But since there's not a whole lot of numbers and multiplying going on, I'm going to do it just here. Remember, when we're multiplying, multiply coefficients first. Since it's just 1 times 1, it's just 1. And then I multiply what is inside the radical next. So I'm going to have to multiply 12 times 6. In your calculator, 12 times 6 makes 72. Okay, so I just did this first arrow right here. I multiplied, I multiplied radical 12 times radical 6. And again, can't do that in your calculator because you will get an irrational answer. But if you know the rules, multiply coefficient times coefficient, multiply number inside times number inside, and you get 1 times the square root of 76. I'm going to do that same process, except I'm going to now use 12, radical 12 times radical 3. So again, there's a 1 in front of the 12, there's a 1 coefficient in front of the 3. 1 times 1 makes 1. 12 times 3, the answer to that, the product is going to go inside a radical. 12 times 3 makes 36. And because this is an addition problem inside, it will still remain an addition problem because I'm multiplying a positive 1 times a positive 1. Okay, so I'm here. This looks good. I'm now going to do my third step after I'm done multiplying, right? Coefficient times coefficient, radical times radical. I'm going to now simplify. Again, I will pitch this video until my eyes turn red. Please, please, please watch the Simplifying Radicals video. You've heard me say it. I mean, we do a lot of simplifying. You really need to have that core skill down. Radical 72. So in my calculator, I have to make sure I have my list of perfect squares. 25, 36, 49, and that should be enough. 4. And now I'm looking at 72 divided by x, and I see one of these on my list. Here we go. So I have the square root of 36 and the square root of 2. And I can stick that 1 in the front if I need to, and there you go. So simplifying radical 72. I'm going to put this guy in my calculator, and I'm going to get 6. Leave the radical 2 alone. Hey! All right. Well, I guess since 36 is on my list of perfect squares, that answer is just going to be a perfect square. I'm going to put that in my calculator. And guess what I get? 6. So I'm just going to bring that plus sign down and put the 6 down. I cannot move further here because this has a radical, this does not have a radical, and if we're talking about adding, I have to have like radicals in order to add them together. Again, my final little check, right? If I'm multiplying, I'm going to put these in my calculator, and what I want you to do as like a little bit of extra work is put these in your calculator and get me what the decimal equals and write it down on your paper so that I make sure that you know that this, whatever the answer to this is, should also be the answer to this, whatever decimal it is. Now, it will not be your final answer, but it is a good way to check that you did the problem correctly and you showed all that good work. Plug that into your calculator, write down the decimal, and that's the last thing you have to do to complete your notes. Be sure you have all of this copied so your notes are complete for class. Thanks so much, guys.